Now we're going to apply the same principles to a diverging lens. Keeping the same idea, I'm going to have our first ray. That one's going to be green. That is going to come in parallel to the axis, and then it is going to reflect going through the near focal point. We'll talk about what that means. Our second one will go through the center, and that one will not bend. The third is going to start aimed towards the far focal point, and it's going to emerge parallel. We will start with our first ray. Line it up, and that is going to go, it's going to come in parallel, and then it's going to reflect as though it's going through the near focal point. So you line up with the near focal point, and it refracts like that. So if you were to trace this one back, it would look like that. It's going right through that near focal point. The next one goes through the center. This is like what we did before. No bend to that. Our last one, we start by aiming it towards the far focal point. It's the one over on this side here. We start aiming it towards the far focal point, and then it emerges parallel. Again, you'll notice that these rays diverge. They don't all meet in one location. So in this case, we trace them back. When that happens, we trace them back. All of the rays wind up meeting at this point, or at least around there, making our image that. You can try this on your own with the other two. Now, if we look at these, we see, what we should see is it getting bigger. Since this is more of a qualitative process than a quantitative process, it doesn't always work out that way, but we're mostly trying to find the general position and the orientation, which we're able to find pretty well. It gets bigger as it goes, at least that's what we should see. All three of these create a virtual image that is upright. Now we will analyze the convex mirror in its natural habitat. Again, we have three principal rays. They're a little different though than with the lenses. Our first one starts parallel, similar to before. And then it's going to go through the focal point. Our second one is going to align with F, align with the focal point, and emerge parallel. Third one hits the center, and it emerges as theta I equals theta R. So it's going to emerge with the same angle that it came in with. There is one mistake that I made with these. When we're dealing with a convex mirror, there is only one focal point and it's on the inside. These should not exist other than, I guess, to just give you an idea for where we're placing the arrow. But there's only one focal point and it's on the inside of the convex mirror. We're going to start with our first one. This one comes in parallel. And then it's going to look like it's going through the focal point. Remember, no light is actually going inside of the mirror. But if we were to trace this back, it would look as though it's following the path of that focal point. Next, our second one, my blue one, that's going to come in as though it's aligning with the focal point. And then, as with rays that go through the focal point, it's going to emerge parallel. We can see that those rays are not going to converge. It's a safe bet that it's going to be on the inside, especially since I think we stated that for these mirrors it is. Now we have our last ray. This one's going to go through the center and emerge with an equal angle. This one can be hard to draw. I'm pretty particular about this, and even I'm not going to use a protractor to get this angle. So what I'm going to do is, there's a reason that you do this one last. Draw the incoming angle, draw the incident angle, and then I'm just going to align it with the converging point. I know that this is circular, but I know this is kind of circular logic, but so long as you really only need 2 of these points to do it. The third is kind of a check. As long as this checks out in the sense of it looks like this angle is approximately equal to that angle, you should be fine. We now have our image. It's just like that. With a convex mirror, with mirrors in general, I believe, it's easier to just do the center one last and force it through that point. So long as it still looks right, you should be fine. Try the next 2 on your own. If we look at each of these, we'll see that all of them are virtual and upright. Concave mirrors. This is our last one. Same idea as the last one. Our first ray is going to come in parallel. And then it's going to go through F, through the focal point. Our second one will align with F and emerge parallel. Third one hits the center and emerges at the same angle. Take a look at this. We'll take a look at this. Comes in parallel. And then goes through the focal point. Remember that with a concave mirror, there is one focal point and it is on the same side as the object. This next one is going to align with the focal point and emerge parallel. Last one, hit the angle, or hit the center, and then you just kind of force it through that point. And as long as it looks like it makes sense, you should be fine. That will place our image there. Try this for the next two, and I'll tell you that one of them gives a virtual image and one of them gives a real image. Try and figure out which one is which. This is going to give us 2 real images and 1 virtual. The ones that are real have the light rays meeting. The one that is virtual has the rays diverging. This is going to conclude the notes for chapter 18. And I hope this is better than chapter 17. Good luck to you, and I'll see you around.